Hello, my name is Maxwell Bowman, and for this week, we'll be taking a look at the electromagnetic spectrum. Light travels as a wave, an electromagnetic wave. When we look at a wave, what we're looking at is the wavelength, which is how long it is from crest to crest, or trow to trow. We also have the amplitude, which is the height of the wave. Another important trait is frequency. To understand frequency, let's look at a wave. Let's watch one wavelength pass. We call the time it takes for one full wavelength to go by the period. I'm cheating a little, but the period should be about 0.66 seconds. That means every 0.66 seconds, we get another wave coming in. Now, to find our frequency, we take f and set it equal to 1 divided by the period. So, that equals 1 divided by 0.66. So this should equal about 1.5 hertz. Hertz is a unit. A hertz, 1 hertz, means that you have one cycle, one full wavelength, per second. Period. Waves travel through electrical and magnetic fields. Your magnetic wave is always going to be at a right angle. It's going to be perpendicular to your electric wave. Electrical fields and magnetic fields are tied together. If you change one, you change the other. Electromagnetic waves travel fast, the speed of light, which we call c. Light travels faster than anything else in our universe. Nothing can go faster than the speed of light. One of the most important discoveries of the 20th century was the fact that electromagnetic waves behave both as waves and particles. So when we look at electromagnetic radiation, we can treat it either as a particle. So for the photoelectric effect, that means some energy goes down and excites an electron, so it releases a photon. Or it acts like a wave, so we can filter out using very special lenses. So electromagnetic waves can have different properties. They can have different frequencies or different wavelengths, which we call lambda. The frequency and wavelength will tell us what type of electromagnetic wave we're looking at. If our wavelength is very big, so if we have a really big lambda, we'll have a radio wave. If we have a really small lambda, we're going to have gamma radiation. The reason this type of radiation is so dangerous is because it's very small, and it can very easily get into your DNA. When we look at a wave, we have a relationship to keep in mind. C equals lambda f. So if I have a wavelength, if I multiply it by the frequency, it must equal the speed of light. If we know one, we can easily find the other. So if I have my wavelength, all I have to do is to divide both sides by frequency, and so I'll get my wavelength equals the speed of light divided by the frequency. So if our frequency gets really, really big, our wavelength has to get small. If our wavelength gets really big, then our frequency will have to be small. So we can say that the wavelength and the frequency have an inverse relationship. If I make my wavelength bigger, like I have with radio waves, then my frequency is much smaller. If my wavelength is very small, my frequency is very big. Let's quickly go through a couple of types of electromagnetic waves. Radio waves have massive wavelengths and the lowest frequencies. They can get up to the size of a building. These radio waves are what you listen to when you listen to the radio. If you listen to FM radio, well, that's frequency that they change. You look at AM radio, that's amplitude. Another type, microwaves. This is what your microwave uses to microwave your food. If you ever get pulled over for speeding, this is probably how they got you, by throwing radio waves at you. Infrared is heat. If you ever use night vision goggles, which cost a couple $1,000s, well, you would see the heat coming off of the building. Visible light is the wavelengths you can see. The ones with the longest wavelength, and therefore the smallest frequency, be red light. The ones with the shortest wavelength, so therefore very fast frequency, that's your purple. Ultraviolet waves, they carry a lot of energy. This is why you wear sunscreen. This is why you should try to get outside, even during the quarantine. You need that vitamin D. X-rays, if you've ever broken a bone, well, those are very short wavelengths and high frequencies. They got very, very high energy, and they're also small, so they can slip through your skin. Gamma rays. These are the scary ones. They're very, very small, short wavelengths, and very, very high frequencies. They can cause a lot of damage if you get hit by them. They can also be used to help kill cancer cells, but they're pretty dangerous. So a reminder, all electromagnetic waves go the speed of light. Nothing can go faster than them. They also have different wavelengths and frequencies. So if you have a big frequency, you have to have a smaller wavelength. You can have a long wavelength and a short frequency, or a short wavelength and a high frequency. So the more frequency you have, the more energy. So those gamma rays, because they have a very high frequency, well, they have a lot of energy. And here's a final view of the full electromagnetic spectrum.